Okay, so for lesson 5.3, we are going to be finding inverses of relations and of functions. Okay, and basically we're going to be discovering what are inverses. Okay, so what makes a function inverse? How do we find those inverses of said functions? So just some vocabulary. Again, just a reminder, this will be a quiz or a test question, so we might make sure we want to know that. A function is a relation in which every input has only one unique output. Okay, so basically every input can only have one output. Now, something new that we're going to talk about today is a special kind of function. So a special kind of function is a one-to-one function. Now, a one-to-one function is a relation where every input has only one unique output. Okay, which is the same as what we've been dealing with before. So that's what makes it a function. However, a one-to-one function has every input has only one unique output and every output has only one unique input. Okay, so one-to-one function is a special type of function. Before, we had talked about this example here. 1 has an output of 4, 2 has an output of 4, 3 has an output of 4. So each of those inputs has only one output. This is a function. However, this is not a one-to-one function because a one-to-one function says that each output can only have one input as well. Okay? So your only one-to-one type functions that you deal with will be functions that look like this, where each number is paired together only once. Okay? So while that other example was a function, it was not a one-to-one function. Okay? So one-to-one functions are each input has only one output, and each output has only one input. Okay? Now, what's unique about one-to-one functions is every one-to-one function has an inverse function. Every one-to-one function has an inverse function, and that's why one-to-one functions are important. So what is an inverse function? Well, an inverse function is the function that results from exchanging the input and output values of a one-to-one function. Okay? So exchanging the input and output values, that is the most important thing that we are going to talk about today. Inverse functions exchange the input and output values. Okay, so what are some synonyms that we can use for that? So exchange, what's different, or what's another word for exchanging? Well, that is just switching, right? You're trading something. You're switching. Okay? Another word for input we've talked about could be domain. It could also be X, or your X values. Another word for output could be range, but we've also talked about how it could be Y. And this is the single most important thing that you should take away from this lesson today. When you are finding an inverse function, or how do you prove that something is an inverse function? You simply must switch X and Y. Switch X and Y. Switch X and Y. That's how you tell that something is an inverse function. You switch X and Y. Okay, so here's an example. I've got y equals x cubed, and it is in green here. Y equals x cubed is in green. And I have y equals the cubed root of x. Okay, now we will learn to graph these functions, but right now I've just went ahead and graphed them for you guys in this picture. And what I want you guys to notice is you've got your blue function here. Okay, that's the cubed root of x. You got your green function here. So based on our definition of inverse functions, are these two functions inverses of each other? Well, the way you can do that is, or tell that, is by looking at their points. So our green function has the point 2 and 8, while our blue function has the point 8 and the point 2. So what is different about those 2 points is your x and y values are switched, which by definition is what an inverse function is. So these 2 functions are inverses of each other because the point was flipped. Instead of 2, 8, it was now 8, 2. Okay, they flipped the values. These 3 points in here you can't really see because they are both points on the graph. But when we come down here, you can see there's a point -8, -2, while down below it becomes -2, -8. The two values are flipped. X and Y are switched. Okay, if we go back to that last slide there is one other important piece of information, and it says that these graphs are symmetric about the line y equals x. And you can see that when we come to this one here. Okay, y equals x, y-intercept at 0, slope of 1. So it's just your line that's running up through the corner. Down on that, and you guys can see that these two functions are symmetric. They are flipped based on this line here. Okay, they are symmetric about that line y equals x. But the most important thing that we need to know about inverse functions is that your x and y are flipped. X and y are flipped. Okay, now, we talked about the vertical line test. The vertical line test says we take a vertical line and we run it across the graph and see, does it ever hit at more than 1 point? Okay, and if it only hits at 1 point every single time, then we can say that something is a function. Okay, if it hits more than 1 time, we say that it is not a function. Okay, well, there is another test, and this other test is to test to see if something has a one-to-one function, and that is your horizontal line test. So a horizontal line test will test to see if a function is a one-to-one function. Okay, which more simply put, because remember all one-to-one functions have inverses, the horizontal line test will test if a function has an inverse. So this is how you can tell if a function has an inverse or not. Okay? The horizontal line test works the exact same way as the vertical line test, except instead of running a vertical line through the graph, you are going to run a horizontal line through the graph. So, for example, not all functions have an inverse. Okay? You can use the horizontal line test to tell if they have a function. So you're going to take your horizontal line and you're going to run it through this graph. Does it ever hit at more than 1 point? Well, yes. You can see here on the parabola multiple times it hits at more than 1 point. So we can say this fails our horizontal line test, which means there is no inverse function. Whereas our cubed function, we've already worked with our cubed function before. Does our cubed function have an inverse? Well, if I run vertical lines through, okay, and a lot of you guys will point to this right here and say it hits at more than 1 spot. It looks like it, but if you zoom in, it actually only hits at 0, 0 there, okay? But you guys can see all of these lines, they run across, they only hit at 1 point. So these pass. This one passes the vertical line test. And since it passes the vertical line test, or not vertical, I'm sorry. It passes the horizontal line test. And since it passes the horizontal line test, that means it has an inverse. Okay? And that is what inverse functions are. That is how we tell if they have inverses. The next video that we go over will be finding the inverses of functions.